Hi, in this video we are going to talk about how to remove items from a binary search tree. So first I'm going to create a helper method, def remove. It's going to get the data we would like to remove. And if the self.root is not a none, so there are items, there are nodes in the tree, then we would like to self.root, we set the root to be equal to the self.remove node, and we just have to specify the data and the root node, self.root. Okay, so let's implement this def remove node method with the self, the data, and the node. Okay, so if not node, it means that if the node is a none, we just have to return with the node. Okay, if the data is smaller than the node.data, it means that the item we are looking for is in the left subtree. So we just have to set the node.leftChild is equal to the self.remove node with the data and the node.leftChild. And maybe you pose the question that, okay, why do we have to do it in such a complicated way? And it's quite important to see that, for example, we would like to get rid of this 5. Okay, in the illustration, in theory, it's quite easy. We just have to get rid of it. But basically, we have to tell the parent of the node we would like to get rid of. So we have to tell the node 4, which is the parent of the node 5, we want to remove, that set the right child to be equal to a none. And basically, we are not able to, if we would be programming in C++ and we would handle references, then it would be very convenient to do it. We just have to tell the parent to set the reference to be a none. But basically in Python, when we hop from node to node and we end up with this node and we set it to be a null, then the parent is not going to know that its right child has been removed. So somehow we have to tell the parent that its right child has been removed. And basically that's why we have to say that the node's left child, basically the node's left child is the one that we would like to get rid of. Basically that's why we have to return the node if it's a none, which means that we set it to a null or a none. Okay, so if the data is greater than the node.data, we have to do the same of course, but on the right subtree, self.remove node, on the data and the node.rightChild. And else we know for certain that we are standing at the node we would like to get rid of. So first of course we have to look for that given node we want to get rid of, and else it means that we are standing at the node, so this is the node we would like to get rid of. We have 3 cases: if not node.leftChild and not node.rightChild. What does it mean? That the left child and the right child are equal to none, so it is a leaf node. I print out that removing a leaf node. Okay, and we just have to delete that given node and return a none. And as you can see, this is why it is a good implementation, because we return a none and we set the node left child, for example, to be a none. So this is how we tell the parent that its left or right child has been deleted. Okay, if not self.leftChild, it means that, what's the problem? Left, no leaf, but left child, it means that the left child is a null, so we remove the right child. So basically we have 3 cases as we have discussed in the theoretical section: removing a leaf node, removing a node with a single left or a single right child, and removing node with 2 children. If the left child is a none, it means that we have a single right child, so removing a node with single right child. Okay, so this is the case when we're removing a leaf node, but sometimes we remove a node that has a left child or a right child. So basically here we print out that removing a node with single right child. Okay, and we just have to get a temporary node which is equal to the node dot right child. Then we delete that given node and we return with that, return with that temporary node. Okay, elif not self.right child, what does it mean? That we remove, so print out that removing a node with single left child. Okay, then we just have to create a temporary node with the node dot left child. Then we delete that given node and we return with the temporary node. Okay, and then basically we end up with the situation when we remove item with two children. So removing, okay, some typo, removing node with two children, okay, and we just have to get the predecessor. So the temp node is equal to the self.get predecessor, as we have discussed in the theoretical section. So we just have to get it on the node dot left child. What's the predecessor? The predecessor is the greatest item in the left subtree. So that's why we put the left child in the constructor, and we have this. I'm going to have a def get predecessor. It's going to get a node, and if the node dot right child is not a none, then we just have to return with the self dot, and we call this method recursively, create predecessor on the node right child. So node right child, okay, and anyways we just return node. Okay, so this is how we get the predecessor, because we have to swap them. I mean, the node data dot data is equal to the predecessor that, sorry for that, I'm going to rename it to predecessor, or no, it's going to be just fine, but this temporary node is the predecessor. So that data, and we just have to call this method recursively on the predecessor. So node left child is equal to the self dot remove node on the temp node dot data and node dot left child. So this is what we have been discussing, that we have three cases. If we would want to get rid of a leaf node, we just have to set it to a null. If we have a single child, we have to decide whether it is a left child or a right child, basically. And we just have to do something like this. We get the right child and return it. We get the left child and return it. And anyways, if we have a node we would like to get rid of with two children, we have to find the predecessor. We have to swap them with the predecessor, and we have to call this remove method recursively. Why? Because we are going to end up with one of the first two situations. Maybe it's going to be a leaf node, or it's going to be a node with a single child. So that's all about the remove method. In the next video we are going to test it. Thanks for watching.